Good morning. Today again I am going to share two questions, that is on unit number 2 SFD BMD, and you can see this question that was asked in asked in 2017, and in this 2017 we have a question to draw SFD and BMD. So now for this, we have to solve problem first by finding reaction. All SFD BMD, without reaction, we cannot draw SFD and BMD. Now, how we will solve this? Just I will explain, and tomorrow I will share the solution of this. Now you can see we have 20 kilonewton load which is acting between the UDL, and for this we have this as 20 kilonewton and 20 kilonewton meter for 5 meters. So where we have to find this value of load? So load we have to find, that is at A, means shear force left of A, shear force right of A. Then we have to find now left of D, and while taking left of D, we have to consider UDL of 1 meter. This UDL also we have 20 kilonewton per meter. So take only 1 meter portion. Then you have to find right of D. Then you have to find at C, and then you have to find at B. Now after this, you have to find bending moment at A. Then we have to find at D. Then we have to find at C, and then we have to find at B, and we have to check, is there any point where we have shear force is 0, and if we have such a point, then we have to find bending moment at that point also. So this was asked in December 2017. Our target to solve problems of last 5 years, that is from SPPU, and then you are in position to understand the things. So questions I am taking A, B both. So now you can see this. The diagram shown in figure is the shear force diagram for a beam which rests on two supports. No couple is acting. This is most important. While we are going for this, no couple is acting. Then draw BMD and load diagram. So though it is mentioned first BMD, first we have to go for load diagram. So now we have to start. We have to give names. So I will give this as A. Then we have this as B. Then we have C. And then we have D. So now at A, we have vertical ordinate in SFD. That means we have vertical load. So I can say this as vertically upward. So we have this as reaction. And that is final minus initial. We will get 90. Then between A to B, we have actually linear line x to the power 1. So we have over here UDL. Then at B, we have again concentrated load acting downward because we are going from 70 to 10. Then from B to C, again, we have x to the power 1. So we have this as UDL. At C, again, we have vertical ordinate, so concentrated load. Then C to B, we have x to the power 1, means we have UDL. And then at D, we have again vertical ordinate, vertical line. So we have again, as it is going up, so we have reaction at D. So likewise, we have to go for, if we have concentrated load, we have final shear force minus initial shear force. And if we have UDL intensity, initial shear force. And if we have UDL, then we have final shear force minus initial shear force upon span. And likewise, we have to find these values. And then we are going to get this as load diagram. And once we know with load diagram, then BMD we can plot it. So daily we are going to be two problems. One problem we are going to be to draw SFD and BMD. Another from load diagram, another from SFD, we have to draw load diagram and BMD. So now we will stop here only. Thank you.